Okay, page 13 of vectors, number 15. So we got three points, okay, three-dimensional points in space. Find RST if vector AC is equal to vector BD. Okay, so basically that's just saying is, okay, vector AC would be found by taking the position C minus the position A. So we would take -1, 2, -2, and we would subtract A, which is -1, 3, 4. Okay, so what would that be equal to? That would be position vector AC. So it would be -1 plus 1, which is 0. It would be 2 minus 3, which is -1, and -2 minus 4, which is -6. So that would be AC. And what about BD? BD would be vector D, RST, minus B, which would be 2, 5, -1. 2, 2, 5, -1. Okay, and that would be R minus 2, S minus 5, T minus a -1, which would be T plus 1. So basically we're going to equate this with this. We're saying that those two are equal to each other. Okay, so let's see. I don't know where I'm going to write this. 0, -1, -6 is equal to R minus 2, S minus 5, T plus 1. Okay, now I'm going to do a lot of this algebra in my head, and I don't want that to confuse you. You can write it out. So R minus 2 equals 0, so R equals 2. S minus 5 equals -1, so S equals 4. T plus 1 equals -6, so T equals -7. Okay, so that was for A. All right. What about this one? If AB is equal to vector AB is equal to vector DC. So vector AB you would find by subtracting vector B minus vector A. Okay, and that would give us 2 minus -1 is 3, 5 minus 3 is 2, and -1 minus 4 is -5. Okay, and so that's vector AB. And what about vector DC? How do we find that? So DC would be R minus a -1, S minus a 2, and T minus a -2. Okay, because DC would be the vector C. Oh, I'm sorry. See what I get by skipping steps? The vector DC is actually the vector C minus the vector D. So I got all those backwards. So vector DC would be -1 minus R, 2 minus S, and -2 minus T. So now let's equate this. Oops. Let's equate this with this. Okay, because those two are equal. 3, 2, -5 is equal to -1 minus R, 2 minus S, and -2 minus T. Okay, and so these are harder algebra equations to solve. So like for example, 3 equals -1 minus R. R is equal to -1 minus 3 equals -4. -4. 2 equals 2 minus S. So that means S is equal to 0. Right? -5 equals -2 minus T. So T is equal to -2 plus 5, which is equal to 3. So T is equal to 3. Okay, so we found the values for RST for part B also. 17. PQRS is a parallelogram. And they give us the 3 points for PQR, and they want us to find S. Use the midpoints of the diagonal to check your answer. Okay, so they tell us that it's a parallelogram, but they don't tell us which points are which. Well, let's see. I'm assuming that they follow the custom of putting the vertexes in order. So PQRS would have to look like this or the reverse. Okay. So let's see. We know PQ and QR. So let's see. If we take, and we don't know S. So we could take the P point, and we could subtract the QR vector, or we could add the QR vector, and we should get the S point, right? So we'll have P, and I'm going to add to the P point the QR vector. I'm sorry, the OP point. The OP I'm going to add to the OP point the QR vector, and then that should give me the S vector. Okay, so let's see. First, I'm going to take QR would be the R vector, the R position vector, minus the Q vector, 1, -2, 5. So let's see what we get. 0 minus 1 is -1. 4 minus -2 is 6. -1 minus 5 is -6. Okay, so that would be the QR. Okay, and the OP would just be -1, 2, and 3. So now I'm going to add this, and I should get, let's see, -2, 8, -3. So this should be the position of, this should be the OS position vector. That should be the point S should be -2, 8, -3. Use the midpoint of the diagonals to check your answer. Okay, so what we should do here is we're going to find PQ and QS. We're going to find the points that are halfway in between those, okay, and see if they're the same, because a parallelogram would have a midpoint between those. So let's see, like P and R, for example. Let's find the point between P and R. So P and R. So like between 0 and -1, the point would be, so midpoint of P and R, midpoint of P and R is equal to, let's see, -0.5. And between 2 and 4, it would be 3. Between 3 and -1, it would be 1. Those are all the coordinates that are halfway in between. What about the midpoint of Q and S? I should get the exact same thing. So Q is 1, -2, 5. S is this thing here, -2, 8, 3. So Q would be, let's see, halfway between 1 and -2 is -0.5. Halfway between -2 and 8 is, halfway between -2 and 8 would be 5, would be 3. And halfway between 5 and -3 would be 1. So it matches. Great, it worked. Okay. The midpoints on those two diagonals is the same, so we're fine. Okay. Vector A, vector B. If we add the two vectors, then what we are going to get is A1 plus B1 for the I direction, and A2 plus B2 in the J direction, and we would have A3 plus B3 in the K direction. What if we subtracted A minus B? Then it would be A1 minus B1, A2 minus B2, A3 minus B3. Okay, and this is just kind of review, except Now we've added the third dimension, right? Because we did this with 2 dimensions, we didn't do it with 3 dimensions. So if we have the scalar k times the vector a, it would be ka1, ka2, ka3. The only difference is now we're working with 3 dimensions. If the scalar 2 is multiplied times the vector x, and that's equal to a, then the vector x is equal to 1/2, the scalar 1/2 times the vector a. And you cannot write it like this, okay? That has no meaning for vectors. For vectors, you have to have something multiplied out front like that, okay? 2 useful rules are vector x plus vector a equals vector b, then vector x is equal to vector b minus vector a. Okay, that's very similar to the algebra rule using regular numbers. If scalar k times vector x is equal to a, then vector x is equal to scalar 1 over the scalar k times the vector a. Okay, and these might seem obvious. Okay, so 1a, solve the following vector equations for vector x. So if 2 times vector x equals vector q, then vector x is equal to 1/2 times vector q. And just do not write vector q divided by 2 because that doesn't really have any meaning. Okay? -3 times the vector x is equal to vector p. So vector x is equal to, and then we could multiply both sides by -1/3. Okay, and that would give us that. E, vector 4 times vector s minus 5 times vector x equals vector t. So to get vector x here, we would, let's see, first I'm going to take vector t and I'm going to subtract 4 times the vector s. Okay, then I'm going to divide or multiply everything by -1/5. So if I multiply both sides by -1/5, then I can get vector x on the left side, and then on the right side I get -1/5 vector t minus 4 times, actually it would turn out to be 4/5, right? Positive 4/5 vector s. Okay, because I multiplied by -1/5. Okay. 2a. Suppose that vector a is -1, 2, 3, and vector b is 2, -2, 1. Find vector x if, okay, so let's try to multiply these out. So 2 times -1, 2, 3 plus vector x, which we don't know yet, equals vector b, which is 2, -2, 1. Okay. So now we could say vector x is actually equal to 2, -2, 1 minus 2 times -1, 2, 3. So let's see, that would be 2 minus, let's see, I'm just going to write this out once, less thinking. Okay, so 2 times -1 is -2. 2 times 2 is 4. 2 times 3 is 6. Okay, now let's do the subtraction. So 2 minus a -2 is 4. -2 minus 4 is -6. And 1 minus 6 is -5. Okay, so that would be our x vector. Maybe we could just like do the algebra first. So we'll do like, we can multiply everything by 1/2, and then we'll get vector b minus vector x is equal to 1/2, -1/2 times vector a. Vector x, we can multiply everything by negative, so we'll get, or we'll just move b over here, so we'll get negative vector x is equal to -1/2 vector a, and then minus vector b. So now we'll multiply everything by negative. So we'll get vector x is equal to 1/2 vector a, and then plus vector b. Okay, now we can just like add them up. So A is negative 1, 2, 3. We're going to multiply it times the scalar 1/2. And then we add to it 2, negative 2, 1. So that would be, the top one would be 2 minus 1/2, which would be 1.5. Negative 1 minus 2, which is negative 1. And 1.5 plus 1, which is 2.5. Okay. Whew. I was probably doing too much of that in my head. Okay, so that's page 13.